Hello, everyone. So, in the previous class, as we were that the mathematical foundations are very much important to understand data science and machine learning. Okay, we did start with linear algebra, where we are available with equations. We have to solve it, converting them into vectors, matrices, because these are the foundations that will help us in solving equations. So we have to convert those data points into this vectors and matrix notations, represent them in this format, and then solve. Many of the algorithms uses the techniques of linear algebra. Then comes probability and statistics. See, if we are available with the data, obviously we have to check out the distribution of it. So probability will help us in drawing the conclusions over the data. What will be the result? What is the chance? Okay, what will be the outcome? Okay, so probability will gonna help us. In a data distribution, there will be a random variable. And whatever value a random variable may possess in that distribution, that's gonna given by the probability. And statistics, obviously, in this distribution, I need to talk about descriptive statistics. I need to talk about inferential statistics. Okay, in descriptive statistics, you will talk about mean, median, mode, variance, standard deviation, all these things. In inferential statistics, you will talk about hypothesis testing. You will be available with a statement, and you need to check whether that statement is correct or not over a given distribution of data. So that will do in inferential statistics. Very important. This section also, probability and statistics. So linear algebra and statistics, 60% of your data science and machine learning. Rest comes your calculus, where you will be performing the differentiation, integration. Okay, and here differentiation is something which is very important, because we will be solving problems. That means we have to perform optimization. Okay, so for that, differentiation is required. What it is, as you continue the lecture series, you will came to know about it. Integral calculus is used in probability. Okay, over continuous variables, that will check out ahead. So this is also important. Next one is this calculus, multivariate, optimization. This will all be considered under calculus only. Information theory, it's also an important concept, because the part of information theory I will be using in algorithms like decision tree. Okay, so it helps us in quantification of information. Quantification means if something is written, I want to convert it in a numerical value. That's what I need to do. That if there is something written in a form of a statement, how I can quantify it, how I can measure the uncertainty in it. What does it what does it mean? I want a numerical value for it. So these all concepts will be studied in information theory. Very important. Graph theory, that will help us in graphical representations, some creating networks. Okay, tree is also a kind of a graph without any circuit. Apart from that, we are having other graph also. Okay, students do study this graph theory here in engineering in one of the subject that is called as discrete mathematics. Okay, and also in data structures graph is present. Okay, and important concept. Okay, so that we will cover ahead. Fine. And rest we are left with some numerical methods that are also been a part of algebra. Okay, so solving the things analytically using some techniques. That means, for example, Fourier transformations, Laplace transformations, Taylor series, etc., etc. There are many of the which are being present in our engineering. Also, the student do study these things in their M2, in their M3 kind of subjects. Okay, so all these mathematical foundations are important for us. Okay, fine. Now, let's get started with linear algebra. This is our first topic. It is a branch of maths that deals with the study of linear system of equations. Okay, so you will be having variable, you will be having constant, I will be organizing them into equations. So all the machine learning algorithms are based upon these equations only. And I want to transform data in form of vectors and the matrices to solve them. Okay, and here in case of linear algebra, you will be seeing eigenvalues, eigenvectors. They will play an important role in solving the equation, in solving a matrix. Okay, so linear algebra is a building block. Okay, and it describe both, for example, vectors. It describe both direction and the magnitude. Yesterday the question came, sir, why you are taking vector only? Why not scalar? So this line, the building block of linear algebra is vector because it is having magnitude and direction both. And I want to represent, कल भी मैंने बोला था अभिषेक, I told I have to represent an object in an empty space. I need to represent that object. I need to represent that point in an n-dimensional space. So how I am going to identify that data point where it is present? तो सिर्फ स्केलर स्केलर तो वैल्यू होती है. एटलीस्ट आई कैन लोकेट. कल भी मैं यही चिल्ला चिल्ला के बोला उसको लोकेट तो करूं मैं कि वेयर इट इज प्रेजेंट द डेटा पॉइंट. Okay, so this space is known as a vector space, collection of vectors added together or multiplied by a real number or a scalar quantity. So just give a direction, give a location for it. So vectors will help me in transformations, and many other applications are there with the vectors. So if vector is there, then linear algebra and matrices and everything will be there. All right. So a strong foundation in linear algebra opens many possibilities, and we are going to explore them ahead. Fine. Here is your 2D vector space diagram. Okay. For example, you are having a point 1 comma 2. Okay, and I am representing it in a form of a vector. Okay, let me share my entire screen now. Okay, so here it is. Fine. This is a vector representation of a point 1 comma 2. Okay, which you are writing in a form of like this 1 2. Okay, and similarly, if any point is present here below, you are representing it as minus 3, minus 4, something like this. Again a vector, minus 3, minus 4, vector. Okay, so Here's the representation. 2D vector space. Why 2D? I am having x axis and y axis both. Two dimensional. Okay. This is the representation. I can perform addition. I can perform subtraction. I can perform many other things over these vectors. You can see. Here is the addition of the two vectors. Okay. And how vector addition has been done? In a very simple way. I'm just adding these two. That's it. And here's the resultant vector. I hope you have seen in physics also. Okay. If you are having a vector, b vector, this is the resultant vector. A vector, b vector, then this is c vector, and c vector is equal to a vector plus b vector. This we have seen in physics also. Vector addition. We can have vector subtraction also. Just change the direction. If this b will be changed to like this, then it will be a vector minus b vector is equal to c vector. If the direction changed. Okay, fine. So here they did a addition of the vectors like this. Okay, fine. Next, direction of the vector. Here is something I already told you. If this is A, this is B, obviously this is A plus B. Fine. That's what I made here. Okay. In my rough template, this is A, this is B, so this is A plus B. A vector plus B vector. It's clear. Okay. But if we change the direction, okay, if we change the direction, let's see. If this is A and this is B, okay, for example, this is A, this is B, okay, so it is saying something like this: A minus B. Okay, just check it out. Okay, so all these are the GIF, okay, that will going to help you in performing the operations over the vectors. Okay, so this is A, this is B, B minus A, and this is A minus B. If you change the direction, it will be A minus B. So by seeing this vectors representations, now understand what kind of operation I need to apply. What would be the direction? All right, fine. Properties of vectors. They are commutative, associative. Okay, many of these properties you have seen in the basic classes also. Fine. So commutative means a plus b equal to b plus a, and a dot b equal to b dot a. So there are two operations in general. One is the addition, one is the dot multiplication. So we can apply these operations over the vectors. A plus b equal to b plus a, and a dot b equal to b dot a. Associative, just take the combination. This is associative. A plus b plus c. So first perform b plus c. That is equal to a plus b equal to c. This is a plus b. First perform a plus b, then add to c. It's all same. LHS equal to RHS. It's all same. Here also. Okay. So with dot operation, it's also associative. Zero element. That means it's an identity in terms of addition. Identity element. For example, if I add 0 to a vector, the result will be the vector itself. It's a zero vector. Okay. And if I multiply a with 1, okay, if I multiply a with 1, that will be additive. That will also be an identity. That will be additive identity. That means 1 dot a equal to a. That is additive identity. Okay, so with 0, a plus 0 equal to 0. With multiplication, 1 dot a equal to a. Okay, I can have distribution also. A dot b plus c equal to a dot b plus a dot c. And inverse also. A plus minus a equal to 0. This is inverse. Fine. All right. So these are properties we have to remember of the vectors. Okay. Hmm. Very important concept which you have to understand. Many students confuse in linear function. Okay. Let me tell you where the confusion is. For example, if I am saying ax plus by plus cz equal to 0, ax square plus by plus cz equal to 0, a square x plus b square y plus c square z equal to 0. Can you tell me which of these are linear? Which of these are linear equations?
First and third, sir.
First and
Third.
First and third.
first and third. What made you to
Yes.
think first and third?
The degree
The
of a
as
variable
the
xy is z.
yes,
Okay, degree of the variable is 1, and here the
one.
variables are x,
X,
y,
Y,
and
Z.
z. Okay, since their degree is 1, it doesn't matter the coefficients are square, it will not change. It will remain linear equation only. But this is quadratic in nature because the highest degree of variable x is 2. So it is not a linear equation. That's what the confusion is. Okay, so this is my linear equation. This is also a linear equation. Okay, however, this is not a linear equation. X square. Fine. Next comes is the dot product. तो डॉट प्रोडक्ट तो बड़ा इंपॉर्टेंट है वेक्टर्स के अंदर. हियर इट इज. डॉट प्रोडक्ट a vector dot b vector. Okay, so there are various use cases of this dot product. That's what you are seeing here on the board. Okay, so I am doing here the dot product of two vectors 135 246. And how this operation is performed: 1 into 2 plus 3 into 4 plus 5 into 6. Okay, that means we have to check out the row and column factor, row and columns, then only the multiplication. यदि आप ये कर रहे हैं कि सर this vector and this vector can multiply, no, ऐसा नहीं होता. this is this vector is of 1 cross 3, यानी 1 row and 3 column. You are having 3 columns and you are having 1 row here, and this vector is of 3 cross 1. That means 3 rows and 1 column. So if this match, then only the multiplication is been done, else not. Okay, they did the same. Okay, so this is how you are going to take a dot product. Apart from it, apart from it, if I'm considering a vector and b vector dot product, the answer is magnitude of a, magnitude of b, cos theta. That is the result. Where theta is the angle between two vectors. We have studied a lot of stuff related to it in physics. ये a है, ये b है, and there is an angle theta between them. So Newton laws, and he already told, this is how I can write. And cos theta is equal to a vector dot b vector upon a b. ये बार है, ये मैग्नीट्यूड बता रहा है. And how you are going to calculate the magnitude of a vector? For example, you are having 2i plus 3j as a vector. The magnitude will be under root of 2 square plus 3 square. That will be the magnitude of a vector. Okay, this is how you will calculate. Fine. They are saying the same thing. Dot product. Okay. Now, next concept is norms or the normalization. Okay. What are these norms? So, you know what happened? Let me show you a diagram. Okay. Fine. It's not been here at the moment. It will come ahead. But let me tell you prior only. Normalization. See, in data science and machine learning, normalization is a very important concept of algebra. Okay, that will measure the size or magnitude of the vector. Okay, I have been asked a question. You are talking about a vector, a vector. There is one more term, unit vector. What is unit vector? That is vector divided by its magnitude is called as a unit vector. Okay, and a vector is formed by many units. By many units. For example, if I say 5 a vector, okay, 5 a cap, something like that, 5 a cap. So unit vector, that means unit, no? It's unit. Unit means 1. Unit means 1. That's a basic. Unit means 1. It's a basic. If I combine all units, I will make a vector. Okay, so unit vector, as you know, vector divided by its magnitude. Okay, so if I am having like this a vector written in the form of, let us say, 3i plus 4j, so its magnitude will be under root of 3 ka square plus 4 ka square, that means 16 plus 9, 25 ka root, that is 5. That will be the magnitude. And unit vector will be 3i plus 4j divided by 5. It will be 3 by 5i plus 4 by 5j. Okay, that's what this vector means. Okay, this is a unit vector. And if I found the magnitude of this unit vector, तो 3/5 का स्क्वायर प्लस 4/5 का स्क्वायर, क्योंकि आपके दिमाग में क्वेश्चन आ रहा होगा, सर वन कहाँ से आया, सर फ्रॉम वेयर वन इज कमिंग, तो देख लो. लेट मी कैलकुलेट द मैग्नीट्यूड ऑफ दिस यूनिट वेक्टर. सो मैग्नीट्यूड क्या होता है? 3/5 का स्क्वायर प्लस 4/5 का स्क्वायर कर लो. ये हो गया 9/25, ये हो गया 16/25. देन इट विल बी 25, 9 प्लस 16, तो 25/25 आंसर आया 1. तो अ वेक्टर हुज मैग्नीट्यूड, तभी मैंने पहले ही बोल दिया था मैग्नीट्यूड इसका 1 होता है, तभी तो दैट्स व्हाई वी आर सेइंग यूनिट वेक्टर. अ वेक्टर हुज मैग्नीट्यूड इज 1 is said to be a unit vector. And I will join all these magnitudes to make a complete vector. कर लेंगे. यूनिट एक लेंथ है किसी वेक्टर की. एंड दिस फिनोमिना of dividing a vector by its magnitude is considered as normal, and it will be a big concept, it will going to be big concept in machine
Sir,
learning.
sir, what is the difference between unit vector and the normalization?
I'm exploring more about normalization. Just give me more time. Okay.
Okay, sorry.
So as I told, normal first I explained the unit vector concept. Okay, unit vector. Okay. Then I am saying this approach has been used here in terms of normalization. Okay. How it has been used? See, I am writing a formula here. LP norm. What does it have? What is it? It's having summation of xi to the power p whole to the power 1 by p. That means it is saying, sir, p, this value which you are writing in x की power p का summation you have to do, and then you have to do 1 by p. What you're writing, that's a normal form of a vector where value of p can be 1, value of p can be 2, and so on. I do the same stuff in calculating a unit vector. जो अभी क्वेश्चन आया, what is the difference? What I'm doing? What I'm doing? I am having a vector 3i plus 4j. This is a vector. When I converted it into unit vector, I got 3 by 5i plus 4 by 5j. Okay. If I take summation, if I take summation of these values with a square, okay, summation means 3 by 5 का square plus 4 by 5 का square. तो स्क्वायर करिए इन वैल्यूज को, उनका करिए समीशन, और फिर क्योंकि दैट इज एक्स टू द पावर पी एंड 1 बाय पी, यानी 1 बाय पी यानी रूट. ओके, ये करिए और इसका पूरा 1/2 करिए. तो ये क्या था? व्हाट इट वाज? ये यूनिट वेक्टर निकालो.
यूनिट वैक्टर
यूनिट वेक्टर था. तो यही तो नॉर्मलाइजेशन है भाई, अभिषेक, है ना? दैट इज अ नॉर्मलाइजेशन वेर यू टुक वैल्यू ऑफ
मीन
पी इज इक्वल टू 2.
हाँ, तो ये यूनिट वेक्टर हो गया, पी
ये
का
यूनिट
वैल्यू
वेक्टर हो गया.
डिफरेंट.
ओके. आई एम हैविंग डिफरेंट टाइप्स ऑफ नॉर्मलाइजेशन, जिससे बड़ा फेमस है L1 एंड L2 नॉर्मलाइजेशन.
सर, तो नॉर्मलाइजेशन जो होगा तो हमेशा यूनिट वेक्टर के ऊपर ही होगा.
हाँ, देखिए
कोई भी नॉर्मल.
देखिए यू कैन टेक. वहां आपने, मैंने क्या बोला, P इक्वल टू 2 लिया है आपने.
सर, तो वहां पे जैसे 3/5 और 4/5 लिए तो
हाँ
वो तो
हाँ
यूनिट वेक्टर है ना,
हाँ
तो
हाँ हाँ
नॉर्मलाइजेशन में हमेशा यूनिट वेक्टर ही आएगा ना, मतलब
हाँ हाँ
नेक्स्ट.
हाँ, नॉर्मलाइजेशन यूनिट वेक्टर हुआ होगा जब P की वैल्यू 2 ही है. व्हेन द वैल्यू ऑफ P इज 2.
ओके.
2, ध्यान देना,
ओके,
2.
पी का वैल्यू दूसरा
1.
होगा तो दूसरा होगा, लेकिन
यदि,
वेक्टर जो होगा वो हमेशा यूनिट ही होगा, यूनिट
हाँ
वेक्टर
हाँ
ही
हाँ,
होगा.
यूनिट वेक्टर होगा. और यदि आपका P इक्वल टू 1 हुआ, इट इज 1, तो ये it is called as L1 normalization when the value of p is 1. Okay, that means if you are having an equation like this, 2x1 plus 3x2 plus 4x3, this is an equation. वहां क्या करा था आपने? p, इनके स्क्वायर करके you took a summation and then इस पूरे का 1/2 करा था.
सर, लेकिन पहले इसको यूनिट वेक्टर में कन्वर्ट करेंगे ना, तो
आ,
2/√2² 3²
वो
प्लस
यूनिट
फोर
वेक्टर
स्क्वायर
वाली बातें हैं, हर जगह अप्लाई ना करें. रुके, वेट. ओके. तो ये आप निकाल रहे हो मैग्नीट्यूड, है ना? इस मैग्नीट्यूड को जब आप इन टर्म्स से डिवाइड करोगे, देन इट विल कन्वर्ट ना इन अ यूनिट वेक्टर, then it will convert na. When you divide 2 by this complete stuff, then it will become a unit vector.
यस सर।
है ना, करोगे वेक्टर डिवाइडेड बाय मैग्नीट्यूड, तभी तो आता है यूनिट वेक्टर। तो ये वेक्टर था, then it going to divide it with the magnitude, ठीक है, then it only it will become a unit vector. अभी मैं सिर्फ उस चीज पे ध्यान दें, नॉर्मलाइजेशन के बारे में क्या कह रहा हूं, व्हाट आई एम टॉकिंग अबाउट द नॉर्मलाइजेशन. सो हियर आई एम सेइंग दैट, हियर आई एम सेइंग कि if I take the magnitudes square doing the summation and dividing it by 1 by 2, this will represent L2 normalization, which in turn said to be Euclidean बोलते हैं इसे. And if I take only the sum of the magnitudes, ठीक है, इसके ऊपर कोई डिग्री p इक्वल टू 1 है. If this is 1, I am taking the summation, it will become 1 by 1. यदि p की वैल्यू 1 है तो, if value of p is 1, then just take 2 to the power p, 3 to the power p, 4 to the power p, p is 1. Okay, so here also 1 by 1. That will be simple addition of the magnitudes of a vector. Okay, coefficients, magnitude तो क्या बोलूं मैं, coefficients of the vectors, it's a simple addition of them. All right, fine. This is called as, this is called as Manhattan and L1 normalization. Okay, L1 normalization or regularization. Regularization. There is a great need of doing data normalization or regularization in machine learning or data science. Okay, very that I will be teaching ahead, telling you ahead, but I did introduce you why मुझे डेटा को स्केल करना पड़ता है. ओके, आई नीड टू कन्वर्ट डेटा इनटू नॉर्मल फॉर्म. ओके, स्केल करना पड़ता है, उसे नॉर्मल फॉर्म में कन्वर्ट करना पड़ता है. रेगुलराइजेशन आई नीड टू डू because there are some issues present in machine learning. One of the issue which is famous, you will understand by the name overfitting. Anyone can tell me about overfitting? What is overfitting of a model? What is overfitting? Yes, what is overfitting?
The model will work only good for the data which we
Huh.
used to build the model.
Okay, model
Hence,
will only behave good for the data over which it has been trained.
ट्रेनिंग डेटा।
Huh.
यस सर,
But
मतलब
for
Yeah,
ट्रेनिंग
testing,
डेटा।
overtraining data.
huh, over the trained data, but for the testing data, model will fail. That's what you are saying.
यस
Okay,
यस सर।
fine. So you all are correct. That overfitting, there are actually two problems: overfitting and underfitting. अब ये फिटिंग भी मैं आगे बताऊंगा. फिटिंग मीन्स you have to fit data points. You have to fit data points. तो हम भी यही करते हैं ना, जब व्हेन वी आर गोइंग टू यूज अ मशीन लर्निंग, तो हम क्या लिखते हैं, मॉडल डॉट फिट. यानी कि भाई जो एक्स और वाई के डेटा पॉइंट्स हैं, यू हैव टू फिट देम. कहां पे? स्पेस में. किस पे? whom, over whom you are going to fit the data points. You will be having actual line made up of the actual data points, and you are having predicted data points. You have to fit these data points over the line. Then we will check the deviation. So this is my actual line, These are my predicted data points. Okay, and obviously that this concept we will be studying ahead in our linear regression, but I'm just telling you fitting. What does fitting means? I need to check whether my predicted points are lying over actual points or not. If they are deviating, there is an error. If they are
सर
overlapping,
अभी तो
if they are overlapping, if they are overlapping, complete overlapping, then we will say this is the best fit. But remember, the issue which raised here, overfitting wala. Okay, because of the best fit, that means we are saying that our training data, training data points, all I achieved from model prediction, training data points, all I achieved from the prediction, model prediction. That means all points were overlapped. But with testing, that means unseen data, I am unable to achieve the fitting. That means when I put unseen data into the model, this is my actual line, and my predictions are coming something like this. Very high deviations, very high deviations, too much error. So, what we want in our machine learning model is not not complete fit, not much deviation. That means we want marginal error in our model. We want this thing. We never expect 100% accuracy from machine learning. No. कभी भी कोशिश मत करिएगा कि हमारे मॉडल की एक्यूरेसी 100% हो. नेवर.
मींस एक्यूरेसी ऑन द ट्रेनिंग डेटा सर ना
हाँ.
100%।
यस, व्हाट यू आर सेइंग?
एक्यूरेसी ऑन द सर बोल रहे हैं मतलब
Accuracy
आप
is
जो
one
बोल
of the
रहे ऑन ट्रेनिंग डेटा।
evaluation criteria, but we never mean that artificial intelligence is going to have 100% accuracy. Humans also don't have 100% how AI can do.
नो सर, सो हियर इज द वी आर टॉकिंग अबाउट द एक्यूरेसी ऑन द ट्रेनिंग डेटा, नॉट ऑन
हम्म.
द
हाँ.
एक्चुअल एक्यूरेसी।
हाँ,
तो
ओवर
अगर
ट्रेनिंग इट इज गुड.
आपका हाँ ट्रेन अगर टेस्टिंग डेटा पे अगर 100%
फेल.
एक्यूरेसी है तो वो तो अच्छा है ना सर।
Fail accuracy per, if it fails over testing, okay,
हाँ,
that means your model is overfitting.
आए थे
Okay,
आए थे
all right, that's the
ये
case.
सर। तो
And in
ये कैसे हुआ, ये मान लीजिए कि अगर टेस्टिंग डेटा पे एक्यूरेसी जितना ज्यादा वो अच्छा है ना।
हाँ,
अगर
उतना
ट्रेनिंग
ज्यादा
डेटा
अच्छा है.
पे
हाँ, हाँ,
हाँ,
वो
अगर
अच्छा है.
ट्रेनिंग डेटा
यस.
पे अगर आपका एक्यूरेसी ज्यादा तो मतलब एक ओवरफिट हो सकता
हाँ,
है।
तो हो सकता है. यस, बिल्कुल सही है. If the accuracy is higher in test data or validation, whatever you want to say, we always expect that accuracy should be higher on these two data. Okay, accuracy of a model should be higher here. If it is higher, that means if it is compatible with training and validation, if it is going compatible, fine, good. That means your model is behaving and it is understanding the patterns in the data. But if there's a dip, huge dip, training accuracy is coming 90% and testing accuracy is coming 60%, this is overfitted model. That means your model is not behaving good on real data. Also, one more case, underfitting. In case of underfitting, your model fail during training only. During training only, it is difficult for it to understand the patterns in the data. That means the accuracy there will be 60, 50, or less than that, 40, something like that. Very low accuracy during training only. So why? If during training only the accuracy is less, that means model is not understanding what is present in the data. So why there is no need to go for the testing? Obviously, it will fail. Okay, so this is underfitting of the model. There might be many issues. We have to resolve all the issues to make our model compatible. So as I was teaching normalization, that means I am having two kinds of normalization, L1 and L2. These two techniques are used to to prevent overfitting in model. prevent overfitting in model.
So, sir, how, sir?
Hmm. How we have to drop some features in the data which are correlated collinear. Okay, so it has been assumed in our data that all the features which are present in it are independent of each other. If we keep the data features which are dependent upon each other, for example, this is your data set, this is your data set, okay, and this is one feature, this is another feature, third feature, fourth feature. If these features are dependent upon each other, okay, they will give you high accuracy during training because of correlation and collinearity. The reason is correlation, correlation. What I expect from ML model, what I expect from ML model, machine learning, to understand patterns in the data, to understand patterns in the data, to draw insights, to extract knowledge. But if the features are dependent upon each other, if there's a collinearity means if there is a point which is present here, the next point is present here, the next point is present here. So here, in this particular case, the ML model is not doing any effort to understand or to extract the knowledge. It is just simply creating a straight line. That means if a model got this point, it can reach to this point, it can reach to this point directly. It's a collinearity. This is not at all learning. I want, because in real world that is not a scenario. The question is, sir, why model overfitted? क्यों हुआ ऐसा कि मॉडल ओवरफिट हो गया? The reason is, in case of real world, we never expect collinearity in the data. It is random. Okay, but if you're training data, it is having the features which are collinear. That means what data comprises of points, and if the points are coming in a line in a sequence one by one, so here model is not doing any effort. Okay, it is just matching the points. It is not at
Means
all
you are
learning.
passing the same information in a different way by
Same
just
information. Yes,
multiplying
same
here.
information is there. It is all same.
तो हाँ, तो एक चीज सर यहाँ पे जैसे मान लीजिए, तो ओवर फिटिंग का रीजन ये हुआ कि कोलिनियरिटी हम
हाँ
एक ही चीज को डिफरेंट तरीका से मतलब उसको फीड कर रहे हैं।
हाँ हाँ,
तो
यस।
तो ओवर फिटिंग को कम करने के लिए यहाँ पे जो नॉर्मलाइजेशन टेक्निक हम लोग L1 या फिर L2
हाँ, L1 या L2
रेगुलराइजेशन
लगाएंगे।
यूज करते हैं, तो
हाँ,
वो फिर कैसे इस चीज को मतलब टैकल कर रहा है,
वो
वो थोड़ा
टैकल
सा
कैसे
बताइए।
करेगा इस चीज को? हाउ इट्स गोइंग टू
हाँ,
टैकल दीज थिंग्स? बिकॉज
जैसे
let us
ग्राफ
suppose we are having an
से
equation
शुरू करके
beta
बताइए,
naught.
जैसे अभी बता
we
रहे
are,
थे।
we are having a equation, for example, beta naught plus beta 1 x1 plus beta 2 x2. This is an equation, it's a linear equation. You know what happens? The question is how it's gonna tackle. I already told yesterday that the value of x and y are available to us because they are present in the data set. The value of feature and target is available to us, they are present in the data set. Only the fact of the matter is, I need to adjust these. Okay, I
ओके
need to
सर।
adjust these coefficients. इनका खेल करना है मुझे. Okay, so what I'm going to do in the regularization, which I taught just right now, I'm having two kinds of regularization. I'm having L1 and L2. In case of L1, I just simply add the coefficients beta naught plus beta 1 plus beta 2. This is what we do in case of L1 regularization. Just add the coefficients and divide this thing to this equation. Okay, divide this thing to the equation. So my y will be now as y cap. It will like this. And the result will be beta naught upon beta naught plus beta 1 plus beta 2 plus beta 1 upon beta naught plus beta 1 plus beta 2 x plus beta 2 upon beta 1 beta naught plus beta 1 plus beta 2 x1 x2. So I'm dividing these normal form, L1 normal form with my equation, and if the value of the denominator is more, if it is increasing more, then overall ratio will be less.
मीन्स कोफिशिएंट का वैल्यू कम
हाँ,
होगा सर, लेकिन
हाँ,
इससे मतलब ओवर फिटिंग कैसे रिड्यूस हो रहा है वो चीज।
हाँ, देखिए,
ये
जैसे ये दिस वैल्यू विल बी मोर, the overall ratio will be less. That means ultimately I
हाँ
want to reduce the coefficient value overall, है ना? Overall I want to reduce this thing, overall I want to reduce this thing. Okay. And in case of L1 regularization, L1 regularization, okay, it makes coefficient 0. It will make the coefficient 0. That's what the L1 regulation do. Okay, so if it makes the coefficient 0, for example, this coefficient will become 0 overall. This becomes 0. 0 multiplied by x1, the result will be 0. So this feature x1 will be dropped from the data, because obviously if I am having the features which are collinear, correlated, okay, what regularization did? It dropped the feature. Okay,
तो ये एक बार फिर से बताइए, जीरो कैसे होगा।
0, as I told, if the value of this coefficient, this complete ratio is getting reduced and reduced very less. Okay,
ओके ओके,
so
मींस
वो जीरो हो
टेंड्स
जाएगा,
टू
इट
जीरो।
विल टेंड टू जीरो. ओके, मेरा ये जो रेगुलेशन है ना, रेगुलराइजेशन L1, जिसको मैं लेस्सो भी बोलता हूँ, दिस इज लेस्सो रेगुलेशन टेक्निक. ये क्या करता है? इट drops the features which are giving overfitting in a data, in a model. Okay, so it is a ratio of, for example, beta naught upon beta naught plus beta 1 plus, ऐसा रेशियो है पूरा. तो ये जो पूरा रेशियो है, इट विल टेंड टू जीरो इन L1 regularization. और मुझे करना क्या रहता है पूरा? What I need to do? I need to find the value of these parameters only. I will be solving for these parameters only. Okay, that's what I'm going to do in my machine learning solution of an algorithm. Because x and y are available to me, I will be solving the parameter coefficients value. तो अभी आगे बताएंगे अल्गोरिदम्स के अंदर व्हाट आई हैव, हाउ आई एम गोइंग टू सॉल्व दीज थिंग्स. ओके, तो आपको इन कोएफिशिएंट्स की ही वैल्यू निकालनी है. दैट्स व्हाट यू हैव टू डू. And in case of regularization L1 regulation mein, it will make it will make this ratio tend to 0, and if this 0 is multiplied by any of the variable present in the equation, overall result will be 0. Okay, so that feature will be dropped. That's it. तो ये काम करता है आपका L1. L2 जो है, L2 regularization, जिसको मैं रिज भी बोलता हूँ, this is called as ridge regularization. Okay, this is ridge. And in case of ridge, what happens? I am taking the squares of the coefficients and this thing. Okay, and this thing, the squares of the coefficients and this thing, I'm going to take, okay, and divide with the equation, the same as I was taking previously. Okay, I'm doing this thing in case of L2
सर
regularization, yeah, ridge
यहाँ
regularization.
एक चीज यहाँ पे जस्ट पूछ रहे हैं, जैसे
Hmm.
मान लीजिए बीटा वन, बीटा नॉट, बीटा टू है,
Hmm.
तो उसमें से जो भी मतलब का वैल्यू छोटा होगा, तीनों में
हाँ,
जो
हाँ,
सबसे छोटा
हाँ,
होगा
हाँ,
उसका टेंडेंसी ज्यादा होगा कि वो जीरो को मतलब अप्रोच करेगा ज्यादा तेजी से,
हाँ, हाँ,
जीरो को।
देखिए.
ठीक है, और
जिसका
हाँ
वैल्यू सबसे
ये
कम
कौन सी
होगा,
है?
those whose coefficient which is very less, for example beta naught is very less, and overall this ratio is
हाँ
very more. Okay, so
हाँ,
this
तो
will
वो
tend to
जीरो हो।
0, this will tend to 0.
ठीक है। हाँ, तो यहाँ पे जैसे जो बीटा नॉट जिस भी वेरिएबल के करस्पॉन्डिंग होगा, तो
हाँ,
उसका
किसी
मतलब हुआ कि वो
करस्पॉन्डिंग
वेरिएबल
वेरिएबल.
सबसे कम मतलब कंट्रीब्यूट कर रहा है मतलब
हाँ, वो
डेटा को
सबसे कम
प्रेडिक्ट करने
कंट्रीब्यूट कर रहा है. दैट मीन्स दैट वेरिएबल इज कंट्रीब्यूटिंग वेरी लेस इन द मॉडल ट्रेनिंग. Okay, that is contributing very less. Whose coefficient is less, that means his contribution is very less. So these coefficients decide the strength of a variable. Okay, these coefficients decide the strength of a variable. Okay, so if the value of a coefficient is less, that means it is less contributing in the model development. Okay, fine. So that's what we do in regularization technique. Very important concept. In machine learning also regulation is there. Deep learning also regularization term is there. I will say regularization or normalization. Okay, there are many terminologies used for it. Here we came across two regulation technique. These are the general regulation techniques. We prefer only these two. Okay, L1 and L2 regularization. In L1 regularization, I am having value of p or the degree as 1. In L2 regulation, I am having a value of p2 or as a degree 2. That's what I am having. L1 is said to be lesso regularization. L2 is said to be ridge regularization. Ridge. They are also called as L1 is said to be Manhattan distance, and L2 is said to be Euclidean distance. This is Euclidean distance. Euclidean. What does Manhattan means? It is simple addition of the coefficient. For example, I am having I am having this representation, and if I need one point is here, this is one point A, and this is point B. Okay, so according to L1 regularization or Manhattan regularization, okay, this this plus this, okay, this plus this is Manhattan distance. That means A0 plus 0B is equal to Manhattan distance. However, if I take the shortest distance between A and B, this is the shortest distance. That is under root of OA ka square plus OB ka square. This is called as Euclidean distance. Okay, here is the Euclidean distance. So if I take Manhattan, it is L1, and if I take Euclidean, it is L2. Okay, so this is L1 regulation, also called as Lesso, and this is L2 regularization, also called as ridge. Both we are going to explore in our first algorithm, that is linear regression, that will take time. Okay.
तो सर इसको कंक्लूज करने के लिए ऐसे बोल सकते हैं कि मतलब ओवर फिटिंग को मतलब रोकने के लिए
हम्म,
मतलब L1 और L2 यूज करते हैं
यूज
मतलब
करते हैं, यस।
ठीक है। और
टू प्रिवेंट
इसमें जैसे
ओवरफिटिंग।
दोनों का यूज करने से ये होता है कि जो भी मतलब जो भी वेरिएबल लेस कंट्रीब्यूट कर
हाँ,
रहा है वो
प्लस
ड्रॉप
कंट्रीब्यूट,
आउट हो
हाँ, वो
जाता है।
ड्रॉप आउट हो जाए। द वेरिएबल विच इज लेस
और उस
कंट्रीब्यूटिंग, प्लीज डोंट कीप इट।
अच्छा तो उससे ओवर फिटिंग वाला कैसे कैसे हैंडल हो रहा है।
हाँ, यस।
हाँ तो सर हाँ तो जैसे जो लेस कंट्रीब्यूटिंग वेरिएबल है वो
हाँ, हाँ,
ड्रॉप हो जा रहा है तो उससे
हाँ।
जैसे ओवर फिटिंग कैसे स्टॉप हो रहा है वो चीज बता।
देखिए, वो लेस कंट्रीब्यूट कर रहा है, दैट मीन सीधी सी
हाँ
बात
हाँ।
है, आप उस पॉइंट को कैसे कैप्चर कर पा रहे हैं, हाउ यू आर गोइंग टू कैप्चर लेस कंट्रीब्यूशन का मतलब क्या होता है? What do you say a data point, a feature is contributing less in a model? That means उसको या उसके पॉइंट को मुझे एक्सप्लोर करने में एफर्ट ही नहीं लग रहा, सीधी सी बात। आई एम हैविंग लीस्ट एफर्ट, आई एम अप्लाइंग लीस्ट एफर्ट टू find that particular point. That means the kind of pattern which I am making using a model, using a machine model during training is a simple, that is simple model। ठीक है, वो सिंपल हो गया। क्योंकि वो सिंपल हो गया, हम क्या करते हैं, मशीन, व्हाट वी डू इन डेटा साइंस एंड मशीन लर्निंग, टू आइडेंटिफाई कॉम्प्लेक्सिटी, टू अंडरस्टैंड कॉम्प्लेक्सिटी इन अ डेटा। तो यदि आप कह रहे हो कि सर कंट्रीब्यूट नहीं कर रहा, कंट्रीब्यूट, इट इज नॉट कंट्रीब्यूटिंग, दैट मीन्स वो पॉइंट इजीली आइडेंटिफाई हो गया। और आइडेंटिफाई कब हो सकते हैं पॉइंट इजी वे में? जब वो एक रेखा में आ रहे हैं, व्हेन दे आर कमिंग इन अ स्ट्रेट लाइन, तभी इजी आइडेंटिफाई हो सकते हैं। और इसका मतलब क्या होता है? कोलीनियर। गॉट इट? तभी नहीं कर रहा वो। दैट मीन्स feature f1 and feature f2 are correlated to each other in a linear way। and we kept both the feature in the data for training. And I'm, if I'm looking forward for f1, I'm also getting f2, I'm getting both. मैं f1 को ढूंढ रहा हूँ, मुझे f2 भी मिल रहा है, दोनों मिल गए मुझे।
अच्छा सर, तो एक चीज, जैसे मान लीजिए दो वेरिएबल है, दोनों हाईली कोरिलेटेड है, मान
हम्म।
लीजिए कि F1 और F2, तो
हाँ
दोनों के कॉरस्पॉन्डिंग जो भी कॉफिशिएंट मान लीजिए बीटा 1 और बीटा 2 होगा,
हाँ हाँ।
तो उसका भी वैल्यू सिमिलर नहीं होगा क्या?
नहीं, नो, उनका वैल्यू बिल्कुल भी सिमिलर नहीं होगा, नॉट एट ऑल।
कॉफिशिएंट का
कोएफिशिएंट
डिफरेंस काफी
बिल्कुल,
ज्यादा होगा।
बिल्कुल हो सकता है, बिल्कुल होगा। ठीक है, इसमें और भी चीजें हैं जो कि आगे हमें पढ़ना है। इट्स नॉट लाइक दैट दे आर हैविंग द सेम कोएफिशिएंट्स। ओके, आप ये बताइए, जस्ट लिसन टू मी, आई एम सेइंग y equal to 10x. Okay, 10x plus 10 x1 plus 30 x2, something like that. If I take 10 common, so x1 plus 3 x2, something like that. Okay, ऐसा करा हमने, that means this is 3 times of x1, just ऐसा समझे, it is 3 times of x1. Okay, तो कोएफिशिएंट अलग हो सकता है। ओके, किसी का कोएफिशिएंट ज्यादा हो सकता है, होगा। इट्स नॉट लाइक दैट दे आर हैविंग द सेम कोएफिशिएंट्स, कोएफिशिएंट आर डिफरेंट। ओके, तो यदि कोरिलेशन वाली बात कर रहे हैं, इफ आई से y इक्वल टू 2x, सो दैट मीन्स इफ y इज ट्वाइस ऑफ x, if x is 1 y is 2, if x is 2 y is 4, if x is 3 y is 6। तो इससे क्या पता चल रहा है, ये लीनियर है, दिस इज अ लीनियर रिलेशनशिप। चाहे तुम y इक्वल टू 2x करो, चाहे 3x करो, चाहे 4x करो, सब लीनियर रिलेशनशिप है, लेकिन कोएफिशिएंट तो अलग है ना, कोएफिशिएंट तो अलग
तो
है।
सर, तो फिर ये बताइए कि जब मतलब ये L1 और L2 रेगुलराइजेशन जब यूज करते हैं, तो उससे हाईली कोरिलेटेड वैल्यू ड्रॉप होता है या फिर लेस कंट्रीब्यूटिंग वैल्यू है वो ड्रॉप होता है?
हाँ, अब देखिए, हमें तो कहा जाता है कोरिलेटेड, कोरिलेटेड फीचर को ड्रॉप करना। ठीक है, हाईली कोरिलेटेड ड्रॉप होता है। अब बीच में क्या मॉडल इतना एक्सपर्ट है दैट इट विल आइडेंटिफाई, दैट इट विल आइडेंटिफाई कंट्रीब्यूटिंग। अजम्पशन है हमारा, ये एक अजम्पशन है जो भी पहले बोल दिया था कि लीस्ट कंट्रीब्यूटिंग फीचर को ड्रॉप करो, द फीचर विच इज लीस्ट कंट्रीब्यूटिंग जस्ट ड्रॉप इट। ओके, बट ऐसा कहीं इनमें लिखा नहीं, उसके लिए फर्दर चेक होते हैं। दैट मीन्स फॉर एग्जाम्पल x1 एंड x2, दीज आर द टू फीचर्स विच आर हाईली कोरिलेटेड। दो फीचर है, let us suppose x1 is highly correlated to y and x1 x2 both are correlated to each other. What we want is x2 to be dropped, इसको हम ड्रॉप करना चाहते हैं because x1 and x2 are correlated. Okay, and but x1 is highly correlated to the target, so it is contributing to the target, and I want कि x1 रहे। ओके, सो द क्वेश्चन जो आपने पूछा, क्या मॉडल इतना इंटेलिजेंट है कि वो टारगेट और फीचर के बीच में भी चेक कर रहा है और विद इन द फीचर भी चेक कर रहा है, विद इन द फीचर ऑल्सो इट इज चेकिंग? क्या ऐसा हो रहा है, वेदर दिस थिंग इज हैपनिंग कि टारगेट एंड द फीचर एंड विद इन द फीचर ऑल्सो? ये ड्रॉबैक है जो आपने बोला ना मुझे, दैट इज अ ड्रॉबैक। ओके, तभी हम ये सब प्रोग्राम करने के पहले ना कोरिलेशन मैट्रिक्स निकाल लेते हैं, कोरिलेशन करते हैं। df.corr is one of the method which we use to find the correlation between the features। ये करते हैं, आइडेंटिफाई करते हैं, और फिर इसमें टारगेट के साथ भी कोरिलेशन निकालते हैं, विच फीचर आर गुड इन विद द टारगेट। तो फर्स्ट यू कैन कैलकुलेट द कोरिलेशन बिटवीन टारगेट एंड द फीचर्स, अमंग द फीचर्स ऑल्सो यू कैन कैलकुलेट द कोरिलेशन। दिस विल गिव यू एन आइडिया कि कौन सा ड्रॉप होना चाहिए, विच फीचर नीड्स टू बी ड्रॉप्ड। ओके, तभी आपका जो क्वेश्चन का ही क्रॉस है वो ड्रॉबैक है कि सर इफ x1 एंड x2 देयर आर टू फीचर, दे आर कोरिलेटेड विद ईच अदर, कौन सा ड्रॉप करूं मैं? आपने कहा सर विच इज लीस्ट कॉन्ट्रीब्यूटिंग, ये मॉडल को कैसे पता चला इट इज लीस्ट कॉन्ट्रीब्यूटिंग दिस वन? मैंने ये पढ़ा है कि वो x1 या x2 किसी को भी निपटा सकता है. गॉट इट? इट कैन ड्रॉप एनी बिकॉज बोथ आर कोरिलेटेड. either I can drop x1, either I can drop x2. Okay, this is been under consideration of the maths applied and the value of coefficients calculated. Value of coefficients calculated. If the coefficient of x1 is high than the x2, okay, and if you apply normalization, then x1 will survive, x2 will be gone, subject to the coefficient values. And we are understanding that if the value of coefficient is less, then it is least contributing. Least contribute ऐसा assumption हमारा आया है कि if the coefficient value is less, so it is least contributing. And since the ratio, the normalization is getting more, so you can drop it. ठीक है? So it's all subject to maths and just making you clear that the model will understand the maths. Okay, model will go across what are the values coming for the coefficient, accordingly it will drop. Okay, बट ये ड्रॉबैक मैंने पढ़ा है कि विच नीड्स टू बी ड्रॉप्ड, क्या होगा उसमें आइदर कर देता है वो, आइदर, बिकॉज बोथ द फीचर्स आर कोरिलेटेड, सो आइदर ऑफ देम विल बी ड्रॉप्ड, ऐसा मैंने पढ़ा है. ओके, एज अ ड्रॉबैक. ओके, विल सी अहेड मोर कॉन्सेप्ट रिलेटेड टू इट, क्योंकि अभी जब लीनियर रिग्रेशन करेंगे पूरा डेरिवेशन होगा, पूरा मैथमेटिकल डेरिवेशन वी विल बी डूइंग, सो देयर विल अंडरस्टैंड क्या काम कर रहा है. ओके, ऑल राइट, फाइन. So still we are having multiple concepts related to it. We'll explore the normalization. अभी just introduction हुआ, मैं overfitting and all these things मैं और आगे बढ़ गया. Okay, I just taught many more things which are not right now in initial level of linear algebra. Okay, we'll see these things in linear regression algorithm. Okay, the next what we have to study is outer product of the vectors and some vector representation and other things, rank, metrics. That's what we will be studying ahead in the next class. Okay, that will cover. Fine.